In this section, we are looking at evaluating a given expression for different values of our variable. Anytime you're evaluating expression, it's basically a substitution problem. That means you're going to take your value of your x and substitute it into the expression wherever you see that x at. Couple things to keep in mind is always use parentheses whenever substituting in values. This just helps to keep your signs in order. Also, make sure that you use your order of operations to go through and simplify. Our first example is to evaluate the expression of negative 4x minus 3, and that is when x is equal to negative 6. So what we want to start off by doing is bring down our negative 4 from our expression. We're going to multiply that by x, which we are now told is equal to negative 6. So again, use parentheses. We now have negative 4 times negative 6. The rest of the expression is the minus 3. We want to bring that straight down. Once we substitute in our value, now we want to follow our order of operations. We have negative 4 times negative 6, so we have to multiply. Negative times negative is a positive, and 4 times 6 will now give us a positive 24. Then bring down our minus 3. Notice now we have 24 minus 3, so we can subtract those two numbers, and it turns out that our expression, when evaluated with x is equal to negative 6, we get back a solution of a positive 21. Another example is, notice we have the polynomial of x squared minus 5x plus 4. We want to evaluate this expression when x is equal to negative 3. This is really important to use the parentheses when substituting our value, especially when you substitute in a negative number. In our expression, it starts out as x squared, but remember that x is negative 3. So that means now we have negative 3 squared. Bring down our next term, which is negative 5 times x, but we also know now that x is equal to negative 3, so we now have negative 5 times negative 3, and then bring down the rest of our expression of our plus 4. Now, starting from left to right, we want to simplify. First thing we see is our negative 3 raised to the second power. So technically that means we have negative 3 times negative 3. Notice that negative times negative is a positive, and 3 times 3 now gives us our positive 9. Next in line we have negative 5 times negative 3. Again, negative times negative is a positive. 5 times 3, is 15. And then bring down our plus 4. Now we can go through and combine like terms. So we have our positive 9, our positive 15, and our positive 4. So we want to add those three numbers together. So notice that 9 plus 4 is 13, plus our 15, and we are going to get a grand total now of 28. The next example we want to look at is involving substituting in a fraction. So our expression that we want to evaluate is 8 times x to the third minus 4x squared plus 9. Same rules as before apply. Bring down our 8. It's going to be multiplied by x to the third power, but we are now told that x is equal to 1/2. So keep our parentheses, and we have 1/2 raised to the third power. The next term is our negative 4 times x squared. So bring down our minus 4, insert parentheses, and we're going to take that fraction of the 1/2 and now raise it to the second power. And our last term up there is the plus 9, so let's bring that straight down. So now we have fractions that we're going to work with. Notice on this first one, 1/2 raised to the third power. means that we're going to take 1/2 times 1/2 times 1/2. So we can keep the 8 from the original problem. And now we have 1/2 times 1/2 times 1/2. If you multiply the three numerators together, 1 times 1 times 1 is our 1. And in the denominator now we have 2 times 2 times 2, which will give us 8. So 1/2 raised to the third power is actually equal to 1/8. Next term, bring down our minus 4. And notice now we're taking that fraction of 1/2 and squaring it. So we have 1/2 times 1/2. Same as what we did a while ago. Multiply the two numerators together. 1 times 1 is 1. And denominators, 2 times 2 gives us a 4. Last term is that plus 9. So again, we bring it straight down. Next thing you want to notice is we've got this 8 times 1 over 8. And if you like, you can write that as 8 over 1. And notice what happens. There's an 8 in the numerator, 8 in the denominator. Those 8s actually divide out with each other. And as they divide out, they leave behind a value of 1. So now we have in the numerator 1 times 1, which is 1, over 1 times 1, which is 1. And you don't have to write your denominator of 1. Bring down our minus sign. And same thing with the 4. You can write that as 4 over 1 if you like to see that fraction in there. And notice there is a 4 in the numerator, 4 in denominator. 4 divides into 4 once, and 4 divides into 4 once. And so now that fraction has disappeared. And we now have 1 times 1. And denominator is 1 times 1 as well. So we don't have to worry about writing the denominator of 1. Last term up there is still our plus 9. So let's bring down our plus 9. So now we have 1 minus 1 plus 9. And notice that 1 minus 1 is actually 0. So now we really have 0 plus 9. And 0 plus 9 will give us a total of 9 for our answer. These problems of evaluation can also lend themselves to solving some other types of problems, such as if we're given an equation and we want to try to figure out if the values for x and y that we're given, do they actually make that equation a true statement? So are they a solution or not? So to check to see if some values that you're given are actually solutions to the equation, it's a substitution problem as well. So notice that it starts out as y, and we are told that y is equal to 48. So in our equation of the y equals negative x squared plus 5x minus 2, wherever we see y at, we're going to put 48 in its place. Same thing true with the x equals 5. Wherever we see x at in the original equation, we're now going to substitute 5. Be careful with your signs. Notice it starts out as a negative x squared. So this negative is going to come straight down. The only thing being raised to the second power is the value for x itself. So that is our 5 squared. Bring down our plus sign. The next term is 5 times x. But we know that x is equal to 5. So now we have 5 times 5. And then bring down the next term of minus 2. So from here we've got to simplify. And notice on the left-hand side it's 48. We can't do anything with that. So we're going to bring that straight down along with our equal sign. Now this negative number here, doesn't have anything to do with the square. So we're going to bring the negative sign down as well. Next thing we see is 5 squared. That is our 5 times 5. So that now becomes 25. Next term is our positive 5 times positive 5, which gives us a plus 25. And then the last term is our minus 2, so let's bring that straight down as well. So notice now we have the equation 48 is equal to negative 25 plus 25 minus 2. Now we're trying to figure out if these values are actually a solution or not. So right now we have this little question mark over here. Are these two sides really equal to each other? So let's see. Bring down our 48, bring down our equal sign, and what happens if we take negative 25 plus 25? Yeah, that's actually 0. So now we have 0 minus 2 sitting on that right-hand side. So now we have 48 is equal to negative 2. Uh-oh. Guess what? That's not equal to each other. So since that's not equal, it turns out that these values that they gave us in the beginning, x equals 5 and y equals 48, those are not solutions. Okay? So these values are not solutions to the equation. For these to be a solution, we would want this last statement that we came up with to be a true statement. So we would have something like 48 equals 48 or negative 2 equals negative 2. I hope these help you doing your evaluation problems and determining if a given order or given values are actually solutions to your equation or not.